11. Greenberg's Congo-Kordofanian family covers his Niger-Congo family plus a small group of more distantly related class languages in the Kordofan. Nigrically is an classificational term revived in 1959 by Murdoch. 12. See Greenberg's chapter in this volume pages 29 to 308 above. Greenberg also draws attention to the fact that the relationship between Malagasy and Malay was likewise observed in the 17th century. 13. Within the southern area of wider affinity, the only complex unit lying largely outside the fragmentation belt is banded. On the other hand, this one complex unit accounts for almost as many languages, around 500, as the combined total of the other 57 units in that area of wider affinity. 14. C.D. Telby, 1970. 313. Methodology and African Prehistory. Intermediate levels of classification continue to figure importantly in the literature. The imposition and maintenance of these arbitrary divisions on the language empire of Africa may in some ways be compared to the history of arbitrary colonial divisions on the political empire of the continent. Greenberg performed the service to African linguistics in drawing attention to the arbitrary use of the term Hamitic as an intermediate level of classification. 15 but was unfortunately responsible for perpetuating the arbitrary use of many other intermediate levels of classification. Doubts by linguists about several of these have already been referred to. 16 but more recently Professor Stewart has published an even clearer rebuttal of the New Congo, the largest of Greenberg's supposed subfamilies. One important result of all this recent work on the Benue-Congo languages was to raise serious doubts about the validity of Benue-Congo as a genetic unit. At first it had been taken for granted that Greenberg was correct in his claim that many COMMO innovations could be cited as evidence, even though in fact he cited only one, the word for child. Williamson reports, however, that when regular sound correspondences are taken into consideration this item turns out not to be confined to the Benue-Congo languages and therefore not to be valid evidence. She further reports that in the whole of Volume I of the Benue-Congo Comparative Word List there is not one item which is valid evidence. 17. WHE and Stewart points out the long-standing doubts which had already existed regarding the external unity of Benue-Congo. One cannot but wonder why comparative linguists have been so reluctant to abandon its use as part of their classificational framework. Tragically, the whole object lesson of Benue-Congo appears to have been lost, and, rather than abandon this and other unproven levels of intermediate classification, Stewart prefers to perpetuate Greenberg's scheme by amalgamating Benue-Congo with KWA and GHA, two equally arbitrary concepts, to form yet another arbitrary subdivision of Niger-Congo, 18 now known as Volta-Congo. WE shall no doubt have to wait for the outcome of more comparative linguistic work before Stewart's Volta-Congo is further enlarged to include the whole of Niger-Congo or the northern area of wider affinity, the one ultimate level of external and internal unity which is clear and undisputed. 15. See Greenberg's chapter in this volume pages 29 to 303 above. 16. C.D. Telby, Opus Cit, page 160. 17. J.M. Stewart, 1976, page 6. 18. Ironically, the only intermediate subfamily of Greenberg's Niger-Congo which is itself clear and undisputed is Monde. The clarity of this division reflects the fact that it is the only one of his putative subfamilies whose ultimate membership of Niger-Congo is itself in any doubt. 314. Appendix to Chapter 12, The Language Map of Africa. Historians should note that a broad acceptance of Greenberg's standard classification rests largely, in respect of Niger-Congo, on his own acceptance of Westerman's grouping or subfamilies of West African languages. The X has already been pointed out, Westerman did not establish the external unity of his grouping. 19 While their clear internal unity demonstrates only that their constituent languages belong to the northern area of wider affinity. Although current classifications of African languages deserve to be treated by historians with reservation, one cannot overemphasize the importance of the language map of Africa as a source of information on the prehistory of the continent. More detailed work remains to be undertaken, and one awaits a new generation of historical linguists who are themselves speakers of African languages. They will be in a position to reinforce the essential groundwork of a close and detailed comparison of neighboring and closely related languages. From this stage, It will then be possible to move back to the wider strategic interpretation of the African language and the P as a whole. Despite its greater degree of linguistic complexity than any other continent, Africa is notable for the fact that 2/3 of its languages belong to a single area of wider affinity, and that a differently composed 2/3 should be confined to the sub-Saharan fragmentation belt. Bantu-speaking Africa is the one region of the continent which has already seen an intensive debate on the prehistorical interpretation of linguistic data. The key to the prehistorical interpretation of such data on a continental scale, however, will be our better understanding of the linguistic relationships within the fragmentation belt, although the scale of the task can scarcely be overestimated. 19. D. Telb. Opus Cit. 315. Historical Geography, Physical Aspects. S. DIARA. Introduction. It is, of course, hard to separate African history from its geographical setting. But it would be fruitless to rely on determinist concepts in order to establish the full complexity of the relationships that have been established between African societies and their respective environments. Each community has reacted in its own way to its surroundings. The attempts made, with varying degrees of success, to order the environment bear witness to the degree to which men are organized and to the efficacy of their techniques for making the best of local resources. But for a changing Africa it is important to look at certain geographical peculiarities which can throw light on the major events of the continent's long geographical and political history. Here the architectural features of Africa as a whole, its extraordinary climatic zonality and the originality of its natural environments have been the inheritances impeding or promoting human activity, while in no way determining its development. In a word, there is nothing simple about the intimate relationships between African nature and the men that live in it, exploit, develop and transform it in accordance with their political structures, technical possibilities and economic interests. Architectural features of the African continent. It is generally agreed that Africa belongs to a very ancient continent which, before breaking up and slowly drifting apart, included America, Southern Asia and Australia. This continent, Gondwana, is said to have been the result of the earliest orogenic efforts of the Earth's crust, which threw up powerful mountain ranges, generally running southwest/northeast. These plications, greatly eroded by long denudation, were reduced to peneplains, of which the largest are to be found in Africa. Geological originality of Africa. Africa's originality can be seen first of all in the exceptional size of the pre-equator, the Atlantic Ocean, Tropic of Capricorn Kalahari, /mountain ranges and high plateau bifold mountains K***, escarpments easy to Rift Valley J circumflex accent D swamp I ... 1 dense forest ILLL savanna and steppe desert. C Sam Main Cape Posey _Good Hope Sea Agulhas _L 2000 kilometers. Lumels. Figure 131 Physical Map of Africa after J. K. Serbo, 1978. 317. Methodology and African Prehistory. Cambrian Insular Shelf occupying most of its surface. This shelf consists of very ancient and very rigid crystalline granite and metamorphic rocks, shale, quartzite, gneiss either in the form of outcrops, which cover a third of the continent, or else covered by a layer of sediment and volcanic material of varying thickness. With the exception of the alpine system of the Maghreb and the Hercynian folds of the Cape and the southern Atlas, Africa and Madagascar form an ancient stable platform consisting of a shield which has undergone no appreciable application since the Precambrian era. Over the shelf, leveled by long erosion, sedimentary formations have been unevenly disposed in sub-horizontal layers, varying in age from early primary to quaternary. These sedimentary series, made up of rough, generally sandy material, are more continental than marine, for the sea covered the insular shelf only temporarily and partially. In West Africa the primary sandstones form an aureole within the outcrops of the Precambrian platform. In southern Africa a large continental thermotriassic deposits make up the Karoo system, in which the sandstone series are sometimes 7,000 meters thick. In the northern part of the continent, notably in the eastern Sahara and in Nubia, the Jurassic and Cretaceous sandstones are intercalary continental. But in the secondary period, marine series accumulated from the Jurassic to the Eocene in the coastal regions and the basins of the interior. They can be seen in the Gulfs of Senegal, Mauritania, Benin, Gabon and Angola, the Chad Basin and the coastal plains of East Africa, from Somalia to Mozambique. From the Eocene onwards, terminal continental fluviatile and wine deposits accumulated in the great interior basins of Africa. All these series of layers, lying on the rigid shelf, were affected not by plications but by widely sweeping distortions which took place from the primary up to a recent era. Regional upwarpings and large-scale subsidences explain the fold and basin structure so characteristic of Africa. In the Tertiary period, with the paroxysm of the alpine orogenesis, more violent vertical movements caused great fractures in East Africa. These form long submeridian rifts framed by faults, the rift valleys. Sometimes they were coupled with volcanic outflows which provided the most prominent reliefs, such as Mount Kilimanjaro with its glacier culminating at 6,000 meters. To the west, the fractures were smaller, but there was intense volcanic activity in the one at the bottom of the Gulf of Guinea, which resulted in the imposing Mount Cameroon 40-70 meters. Paleoclimatic influences. Following the orogenetic movements, the African continent was affected by long phases of erosion which were apparently fairly slow in all the geological eras. The GHA phases of stabilization were accompanied by resumed erosion, which resulted in the formation of vast flattened surfaces. In this process of evolution the most important factor was climatic variation, and the most remarkable of such variations took place in the Quaternary. Alternating 318. Historical geography, physical aspects. Humid and semi-arid climates resulted in phases during which rocks were weathered and erosion in linear or sheet form took place. The low-lying areas were filled in and hard rocks made to project, often forming isolated reliefs emerging abruptly from the flattened surfaces. There are a great many of these inselbergs in the regions south of the Sahara. In the Quaternary, climatic changes and variations in sea levels were coupled with considerable adjustments to the pattern produced by successive cycles of denudation and accumulation during previous periods. Paleoclimates are responsible for the Sahara, whose numerous stone artifacts and equatorial-type fossil fauna prove that in ancient times it had a humid climate favorable to human settlement. But during the Quaternary, increased or diminished rains resulted in an extension of the existing climatic zones either north or south. Thus pluvial periods considerably increased the proportion of the total surface of the continent suitable for human life. Arid periods, on the other hand, brought about an extension of desert regions beyond their existing limits and made the Sahara a climatic hiatus between the Mediterranean and tropical worlds. Nevertheless, the Sahara, which covers nearly a third of the continent, extending over some 15 degrees of latitude, has never been an absolute barrier between north and south. Inhabited by nomads, it has been crossed by caravan routes for centuries. It has not prevented communication between tropical Africa and the Mediterranean from ancient times to our own, but it has acted as a filter limiting the penetration of Mediterranean influences, especially in agriculture, architecture and crafts. So the widest desert in the world has played a vital role in geographically isolating the large part of Africa. Massiveness of the African continent. The vigor and definition of Africa's physical features distinguish it from all the other continents. Africa's massiveness and heavy relief are the result of a long geological history. A glance at the map shows that Africa, with its 30 million square kilometers, stretches over nearly 72 degrees of latitude, from Ras Ben Saka 37 degrees 2 im, near Bizerta to Cape Agulhas 34 degrees 5 is. There are some 8,000 kilometers between these two extremities of the continent. Laterally there are 5,700 kilometers between Cape Verde and Cape Guardafui. The greater part of the continent, some 2/3, lies above the equator. The continent dwindles in the southern hemisphere. Africa's massive nature is underlined by its lack of the deep coastal indentations present in Europe and Central America, for instance. Moreover, islands are not a significant part of the continent, whose sculpted form is vigorously enhanced by its simple outline and weakly developed continental platform. Any lowering of the sea level would have little effect on Africa's shape, since the 1,000-meter bathymetrical contour is generally close to the coast. The continent seems even more massive because of the heavy relief, often in the form of plateaus, the edges of which rise to form coastal folds, which 319. Methodology and African prehistory river complexes cross with difficulty. Despite its few plicated ranges, Africa has a remarkable average altitude of 660 meters because of the orogenic pressures which in the Pliocene were characterized by vigorous fractures and upthrusts in the shelf. Beneath an apparently simple relief, however, there are considerable regional differences. The Maghreb, for instance, has a marked individuality, being related to Europe through its mountain ranges and petition relief. It has two major mountain areas, the Tell and Northern Rift Ranges, and the Southern Atlas. These ranges form long east-west bands between Mediterranean and Sahara. There is another family of reliefs in the enormous region of Northeast Africa, West Africa and the Zaire Basin. Here the predominant features are plains, basins and low plateaus surrounded by mountainous folds. The largest basins in this area, the heart of the continent, are the Niger, Chad, Zaire and Bahr el Ghazal basins. Eastern and southern Africa are the continent's highland regions, with altitudes exceeding 1,500 meters in many places. The southern highlands are bounded by a marginal fold, the Great Escarpment, dominating the coast with a rocky wall 3,000 meters high in places. But the originality of East Africa lies in its powerful reliefs caused by tertiary tectonic movements. The shelf was violently raised and deep cuts were made by faults and fractures. At the same time it was affected by a violent volcanic movement. The summit of the Abyssinian Massif, consisting of a great upwarping surmounted by over 2,000 meters of lava, rises to more than 4,000 meters. Rift valleys stretch over 4,000 kilometers from the Red Sea to Mozambique. The rift valleys, which have played a remarkable role in the movement and settlement of peoples, contain a series of lakes, including Lakes Nyassa, Tanganyika, Kivu, Edward, Mabuta, former Albert Victoria and Turkana Rudolph, and are bordered by gigantic volcanic mountains, the most famous of which are Mounts Kenya and Kilimanjaro. Geographical isolation. Because of its massiveness and heavy relief, Africa has been isolated until recent times. Apart from North Africa, which looks towards the Mediterranean world, the rest of the continent remained for centuries outside the major flows of trade. True, this isolation was never absolute, but it had a great deal of influence on many societies which developed in geographical isolation. Detached from the Old World when the continents drifted apart, Africa nevertheless has one point of contact with Asia in the Suez Isthmus, which was the corridor for great prehistoric migrations. The greater part of the African coastline borders two oceans which until modern times were not used to an equal degree. The Atlantic was not used before the 15th century when the great seafaring explorations began from Europe. Before that time, the techniques of navigation under sail did not allow Arab seamen, for instance, to travel beyond the Sahara coasts. For 320. Historical geography. Physical aspects. Their ships could not sail into the trade winds which blew southwards all the time. The Indian Ocean, however, had long helped to promote contacts between East Africa and Southern Asia. Arab and Indian sailing ships were able to sail to Africa and return to their home ports, aided by the alternating monsoon winds of the Indian Ocean. The intensive relationships established between East Africa and the world of the Indian Ocean were restricted to the coast, for the seafaring peoples of Asia wished to trade rather than to colonize the interior. The influence of the maritime civilizations of other continents did not penetrate very far into the interior of tropical Africa, most of which remained outside the Old World. Traditionally, the inhospitable character of Africa's coasts has been put forward as the reason for its isolation. The lack of indentation means that there are few harbors along the coastline, which is low-lying and sandy. Rocky coasts are few and far between in West Africa, but there are more of them in the Maghreb, in Egypt along the Red Sea and at the southern tip of South Africa. In West Africa, the coasts from southern Senegal to Guinea and the Cameroon and Gabon coasts are characterized by RIAs. These are vast estuaries resulting from the submersion of ancient fluvial valleys, but most are silted up. Some of the low-lying coasts, swept by tides, have mangrove swamps, especially in the region of the Rivieres du Sud reaching to Sierra Leone, in the delta of the Niger and along the coast of Gabon. Elsewhere, offshore bars border the continent, in places isolating lagoons like those in the Gulf of Guinea. Finally, there are coral reefs along the Red Sea, the Mozambique Channel and the coast of Madagascar. The inhospitable nature of the African coast has been largely attributed to the heavy surf, breaking in powerful, regular waves, which made it hard to land in some coastal regions. but coastal inhospitability has been exaggerated. The Mediterranean coast did not prevent centuries-long trading between North Africa and the interior. The lack of natural harbors is also put forward in explanation of tropical Africa's isolation until recent times. But one need only list the sites attractive to sailors for navigation to see how rich Africa is in this respect, both on the Atlantic and on the Indian Ocean coasts. In any case, these have never been insurmountable obstacles, for Asian and, later, European influences have left a strong impression on the peoples of Africa. Their isolation was only relative. The factors doubtless explain better why the African coastal peoples have taken so little interest in major seafaring ventures. Climatic zonality of Africa. Living conditions in Africa depend in the main on climatic factors. The symmetry and great size of the continent on either side of the equator, its massiveness and relatively uniform relief combine to give the climate a zonality unparalleled elsewhere in the world. Africa is highly unusual in its successive climatic bands parallel to the equator in both hemispheres. 321. Methodology and African prehistory. African rainfall conditions gradually worsen towards the higher latitudes. Because Africa is widest in the intertropical zone, it is the most uniformly hot of all countries. This heat is coupled with increasingly dry conditions towards the tropics or with a generally higher degree of humidity in the lower latitudes. Cosmic factors in this eminently intertropical continent. Climatic differences depend much more on rainfall than on temperature, which in any case is high all the year round in most regions. Rainfall and heat are in any case primarily connected with cosmic factors, namely, the latitude and the apparent movement of the Sun. The Sun reaches the zenith twice a year in all intertropical regions, but reaches the tropics of Cancer and Capricorn only once, on June 21st, the date of the summer solstice, and December 21st, the date of the winter solstice in the northern hemisphere. It reaches the zenith twice a year at the equator, at the spring equinox March 21st and the autumn equinox September 21st. The Sun in its apparent movement never goes very low on the horizon. This is why temperatures are high all the year round in the intertropical zone. In the regions near the equator, where the Sun's apparent position oscillates round the zenith, there is no hot season, for there are few seasonal variations in temperature. There are some 3 to 4 degrees of difference every year. But as we near the northern and southern tropics, there is an increasing contrast in temperature. In the Sahara there are wide variations, some 15 degrees, between the average January and July temperatures. The northern and southern tips of the continent, which belong to the temperate zones, have contrasting thermal regimes, with wide annual variations resulting from the contrast between cold winters and hot summers. Moreover, daily variations can be as high in the Mediterranean region as in the intertropical zone. Cosmic factors determine two major types of thermal regime, regular in the equatorial latitudes and increasingly varied closer to the tropics. Rainfall mechanism. The reason for the seasonal variations in the African climate is the existence of major centers of atmospheric activity which set in motion air masses of tropical or equatorial, maritime or continental types. There are permanent tropical anticyclones, or high-pressure centers over the Atlantic, one in the northern hemisphere Azores anticyclone, the other in the southern hemisphere St. Helena anticyclone. There are two further anticyclone cells, one over the Sahara, the other over the Kalahari. These continental anticyclones are seasonal and play an important part only in the northern and southern winters. In summer they are weaker and are flung back to the tips of the continent. Another major atmospheric activity is the low-pressure zone centered on the thermal equator, oscillating from latitude 5 degrees S in January. 322. Historical geography. Physical aspects to latitude 10 degrees N in July. Surface winds flow out from the anticyclones towards the equatorial low-pressure zone, the trade winds which sweep the intertropical areas. The Azores anticyclone sends out fresh, stable winds, the northeast Atlantic trade winds, affecting only a narrow fringe of the Sahara coast as far as Cape Verde. The high anticyclone over the Sahara is the source of steady northeasterly continental winds which are dry and relatively cool, but warm up as they move further south. The easterly harmattan, burning and dry, blows with great regularity over the whole of the Sahel from Chad to Senegal. It is accompanied by sand, or dust storms bringing dry mists. In the southern hemisphere during the winter, There are also relatively dry hot wines in some parts of the Zaire Basin. But above all in the southern winter, corresponding to the northern summer, low continental pressures centered south of the Sahara attract maritime trade wines from the St. Helena anticyclone which bear northeast after crossing the equator. This is the Guinean monsoon, which thrusts beneath the harmattan, flinging it northwards and upwards. At the point where these air masses of different direction, temperature and humidity meet, there is a zone of intertropical convergence, or an intertropical front, which gives rise to the rainy seasons. During the northern summer May-September the intertropical front, running east-west, moves from latitude I0 degrees to 20 degrees N, thus allowing the southerly trade winds to bring humid air masses towards the Guinea coast, thus beginning the rainy season. In winter, the convergence zone occurs in the Gulf of Guinea, touching the coast in Cameroon and cutting across the southern half of the continent to the Mozambique Channel and northwest Madagascar. North of the equator, West Africa is dominated by dry continental wines. South of the equator, the convergence of the southern continental trade wines with air masses from the maritime trade wines coming from the northern Indian Ocean brings rain. The general mechanism of the climate may be modified by geographical factors such as marine currents, relief and coastal orientation. The constant cold currents on the Atlantic side of Africa are symmetrical on either side of the equator. In the north, the Canaries current, set in motion by winds from the Azores anticyclone, follows the coasts from Gibraltar to Dakar, bringing lower temperatures and fog. Around latitude 15 the Canaries current turns west. Its counterpart in the southern hemisphere is the Bella current, set in motion by winds from the St. Helena anticyclone. This brings low temperatures and dense mists all along the coasts of southwestern Africa, before it turns west at the level of Cape Freo. This is the reason for the coastal deserts of Mauritania and Namibia. Between the two cold Atlantic coastal currents of the Atlantic facade is the equatorial Guinea countercurrent, which displaces warm water masses from west to east, increasing atmospheric humidity and instability and hence the possibility of rain along the coast from Conakry to Libreville. The circulation of marine currents on the Indian Ocean side takes a 323 methodology and African prehistory. Different form. The equatorial waters pushed towards the continent by southeasterly winds from the anticyclone centered east of Madagascar form the warm Mozambique current flowing southwards and continuing further as the Agulhas current. This brings humidity to the southeast coast of Africa. North of the equator, the marine currents reverse with the change in wind direction. In summer, for instance, the hot northeasterly current flows along the Somali coast. In winter a cold current flows from Arabia towards the equator. The relief of Africa, despite its relative uniformity, has an influence on the climate, for it acts like a draft excluder, a veritable screen impeding access by the humid maritime air masses to the central basins, interior plateaus and rift valleys where varying degrees of aridity prevail. The lie of the coast in relation to the direction of the rain-bearing winds also affects the climate. Sectors directly exposed to the southwesterly monsoon, especially when they are mountainous, have the highest rainfall in West Africa, nearly 5,000 meters in the Republic of Guinea. In southern Africa and Madagascar, the coasts perpendicular to the direction of the maritime trade winds receive heavy rainfall. But coastal sectors parallel to the direction of the winds and without notable relief, such as those between Cotonou and Accra and in Somalia, receive less rain. In Africa, seasonal climatic patterns are in the main determined by the amount of rainfall. The amount of rainfall decreases gradually from the equator to the tropics, and the Sahara and Kalahari deserts have less than 250 meters of rainfall a year. Decreasing precipitation totals are coupled with increasingly marked contrasts in seasonal rainfall patterns as we go north. In the regions near the equator with permanently low atmospheric pressure, rain falls all the year round, but there is considerably less at the solstices. Further north and south, rainfall is concentrated in the single period corresponding to summer in either hemisphere. The rainy season is thus contrasted with a dry season which becomes increasingly long as we approach the tropics. But the two tips of the continent, the Maghreb and the Cape Province, are unique in that they have winter rains. These regions have a middling rainfall irregularly distributed over the land. Climatic zones. The variations in total annual rainfall and seasonal distribution of rainfall divide Africa into major climatic zones. 1 Equatorial climates characterize the central regions on either side of the equator, which see 2 equinoctial passages of the intertropical front bringing heavy rains. From southern Cameroon to the Zaire Basin there is abundant rainfall all the year round. The GHA air is saturated with water vapor all the year round. The GHA annual total rainfall generally exceeds 2,000 m. In this humid atmosphere there is little monthly variation in temperature. The year average is 25 degrees C. 324. Historical geography, physical aspects. To the east, in the equatorial regions under the climatic influence of the Indian Ocean, we find the same rainfall patterns, but with an annual total of less than 1,500 m. The GHA annual variations of temperature are more marked than on the Atlantic side of the equatorial zone. Diurnal temperatures are higher in the regions which, climatically speaking, belong to the Indian world. 2 tropical climates are found in the wide areas influenced by the movements of the intertropical front north and south of the equatorial zone. Northwest Africa, between latitude 40 and the Tropic of Cancer, has a variety of climates, ranging from 2 equinoctial passages in the south to a single solstitial passage in the north. On the coast of the Gulf of Guinea, the climate is subequatorial or Guinean, without a dry season but with heavier rains when the sun reaches its zenith twice a year. The orographical effect of the coastal screen condenses the strong humidity borne by the southwesterly monsoon. The GHA coastal fringe from the Republic of Guinea to Liberia has over 2,000 m of rainfall a year. The Sudan region further north displays several aspects of the intertropical climate. There is a humid variety and a dry variety associated with the proximity of the desert. At higher latitudes the 2 passages of the intertropical front are less and less distinguishable. This means that 2 seasons, wet and dry, alternate in the intertropical zone. Between the 2 extremes of the heavy equatorial rains and the aridity of the Tropic of Cancer, we find the following gradations. In the first subzone with annual rainfalls between 1,500 and 2,000 m, rain falls more than 6 months in the year. Annual temperature ranges are higher than those of the equatorial zone. The central subzone is drier, rain falls only 3 to 6 months a year, totaling 600,150 mm. Here temperature ranges show a marked increase. The northern subzone, known as the Sahel in West Africa, has less than 600 m of rain, falling in less than 3 months. Rainfall is increasingly irregular and there are wider variations in temperature. South of the equator there is a similar latitudinal distribution of tropical climatic variations, but the gradations are more marked because southern Africa is less massive and because of the height and size of the relief dominating the coastal plains bordering the Indian Ocean. The GHA convergence of the equatorial maritime air from the northwest and the tropical maritime air from the east brings abundant rains to the coasts of Mozambique and eastern Madagascar. The GHA Atlantic coast, however, is dry because of the cold Benbella current which is responsible for the Namib Desert. 3 desert climates characterize the regions on either side of the tropics. Rainfall is less than 250 m and highly irregular. The GHA whole of the Sahara, the largest hot desert in the world, has less than 100 m of rain a year. But there are gradations because of the oscillation of the Sahara anticyclone which between the solstices moves up to the Mediterranean or descends to low latitudes. In the former position it helps monsoon. 325. Methodology and African prehistory. Infiltrations to penetrate. In the latter it brings polar air. These oscillations distinguish the northern Sahara, with its Mediterranean rains in the dry season, from the central Sahara, with practically no rain, and the southern Sahara, with tropical rains in the hot season. At the Tropic of Capricorn, the Kalahari Desert is more open than the Sahara to oceanic influences from the southwest, for here the continent is narrower and the influence of the anticyclonic cell on the climate is accordingly reduced. Thus there is greater humidity and less heat. For the originality of the Mediterranean climates in the Maghreb and at the southernmost tip of Africa lies in the fact that the winters are cool and rainy and the summers very hot and dry. The Mediterranean climate with temperate zone winds is characterized by the passage in winter of humidity-bearing ocean cyclones. Sometimes there are invasions of polar air with intense cold, frost and snow, notably in the mountain ranges of the Maghreb. The GHA dryness and heat of the summer are caused by the winds blowing from the neighboring deserts, the Sahara in the northern hemisphere, the Kalahari in the southern hemisphere. African bioclimatic environments. In Africa, probably more than anywhere else, human life has been organized in natural contexts which are above all bioclimatic environments. Climate and relief combine to determine major regions, each of which has its own hydrological, soil and botanical characteristics. Outflow of continental waters. The climatic diversity is reflected in hydrography. But in Africa the flow of water to the oceans is far smaller than rainfall would suggest. More than half the continent's surface is composed of regions either with no drainage at all or only draining internally. Moreover, river systems find obstacles in their way. Their profiles consist of gently sloping stretches connected by abrupt rapids, falls and cataracts. Hence much of the water that they drain undergoes permanent infiltration and intensive evaporation through stagnation in the basins, rifts and depressions of the plateau. Organization of hydrological networks. Vast areas of the continent with little or no rainfall have no permanent water courses. But the dry Mediterranean area receives some violent rains which trickle into sheets of water and sometimes concentrate in wadis. These are finally emptied through water evaporation and infiltration. In regions with sufficient rainfall, in tropical or equatorial climates, the major rivers and their principal tributaries form organized networks which collect part of the water from the basins and empty it, often under difficult conditions. The GHA basins in which most of Africa's river systems are formed have peripheral. 326. Historical geography, physical aspects. Bridges which are not conducive to good drainage to the sea. The GHA continental waters are evacuated through the coastal folds by deep narrow gorges, with frequent changes in gradient on the lower reaches of some of the major rivers. The GHA Zaire has 30 rapids between Stanley Pool and the estuary. The Zambezi Falls end meters at the Victoria Falls before plunging into the Kariba Gorge and passing over several basaltic cataracts. DOWN, stream from Khartoum. The Nile passes through 6 rapids, the cataracts, before it reaches the Mediterranean. All the other large rivers, Niger, Senegal, Orange, Limpopo, have stepped profiles, notably in their lower reaches. It is easy to understand why it is so hard to navigate the rivers of Africa, which appear to be very poor channels of communication. Nevertheless, in the past they have encouraged fruitful contacts between different peoples of the continent. Between the major river systems there are jumbled networks of streams, pools and swamps, ill-organized and with no regular drainage to the outside. Sometimes these waters are stagnant or are the outcome of the seasonal flooding of adjacent rivers. Sometimes, on the other hand, they feed such rivers, which in the geological past developed in subsidence basins at the bottom of which lakes were formed and alluvium accumulated. Exterior drainage became possible as a result of tectonic movements, the hitherto enclosed lakes draining through rift valleys or faults. River captures, resulting from these tectonic movements or morphological change, have also doubtless contributed to the present shapes of the hydrological systems. But internal drainage can also be seen in the Chad and Okavango basins, occupied by shallow lakes and marshes which become impressively large when the seasonal streams make their contribution. There are, however, other subsidence basins with outlets to the ocean with a similar tendency towards internal drainage. These are the marshes of Makinabadianer Niger Delta, those of the Bahr el Ghazal in the Sudan and the Zaire Basin. African river regimes all over Africa. Rainfall patterns regulate the hydrological regimes. Seasonal variations in the amount of water in the rivers depend on the annual rainfall. Watercourses in the equatorial regions are regular, with abundant water all the year round. Nevertheless they do have high water periods, corresponding to the times of the equinoctial rains. In the tropical zone the high water period corresponding to the rainy season, the summer solstice, is followed by a period of sparse rains during the dry season. The regime is thus one of strong contrast. Moreover there is a gap between the times when the rains fall and the waters rise, because the waters flow slowly down the slopes, which are mostly gentle. In the subarid regions, the wadis flow intermittently when rare but violent rains cause sudden spats which are, however, short-lived since the waters are lost downstream. In the Mediterranean zone, the violent downpours and the presence of mountains turn the rivers into torrents. 327. Methodology and African prehistory. These rivers are highly irregular, in spate in winter and at a very low level in summer. The white water courses in this climatic zone are wadis with an intermittent flow. The great African rivers with networks extending over several climatic zones fall outside this simple general scheme of things. They are characterized by complex regimes, with seasonal variations in flow changing from one end of the river to the other. The major African rivers. There are a few great rivers, among the largest in the world, which drain vast basins, almost all of which are in the intertropical zone. Their regimes depend on the rainfall supply on the slopes of their basins. The Zaire is the most typical example of an equatorial river with two equinoctial maxima. The Zaire river system extends over nearly 4 million square kilometers between latitudes ∅2 degrees S and 0 degrees N. Through the intermediary of the Kasai and the Lualaba, it crosses the southern regions with maximum rain at the solstices. Its principal tributary in the northern hemisphere is supplied by rainfall at the northern solstice, and through much of its course it runs through regions with two equinoctial maxima. The combination of different intermittences gives Kinshasa a hydrological regime with two maxima March and July. The Zaire is a full, regular river whose annual average flow of 40,000 meters 3/s is exceeded only by that of the Amazon. The Nile, which, through its parent branch, the Kagera, rises in Rwanda and Burundi, receives equatorial waters which spread out into the swamps of the Bahr el Ghazal. After passing through Lake Victoria, it is reinforced by tropical affluents from the Ethiopian mountains. The HE Blue Nile and the Abra, with their solstitial maximum regime, enable the Nile to cross a huge desert area before reaching the Mediterranean. Although, with 6,700 kilometers, it is the longest river in Africa, the Nile is not very powerful. Its average annual flow is less than 3,000 meters 3/s. Nevertheless, from antiquity it has been one of the world's most useful rivers. The Niger, whose basin stretches from latitude 5 degrees N to latitude I6 degrees N, has a more complex regime. It flows in a large, unusual loop. It rises in the mountain fringe of the Atlantic, flows towards the Sahara, then turns towards the Gulf of Guinea, into which it flows through a vast delta. Its upper and lower reaches cross southern regions with a humid tropical climate. The middle reach flows through an interior delta with a succulent climate, and with difficulty it curves inwards in the sub-desert region of Timbuktu before receiving an increasingly large volume of water downstream. The rainy season brings two simultaneous floods, one in the upper and one in the lower reach. But the former, visible as far as Nigeria, gradually declines because of evaporation and infiltration in the dry tropical zone. The second, which is visible from northwestern Nigeria onwards, continues downstream because of the local solstitial MVXIMUM rains. The HE 328. Historical geography. Physical aspects. Niger receives and is swelled by the Benue, its major tributary, in its lower reaches. African soils. The geographical distribution of the soils follows a zoning influence by climate. The various soil formations are in the main the result of the action of water and temperature on the local rocks. In the tropical regions, warm, abundant, acid rains wash the rocks, dissolving basic minerals and carrying them deep down. In the very humid, low latitudes, up to 0 degrees N or S of the equator, the chemical decomposition of the rocks results in the formation of orolitic soils. These are generally of loose reddish clay, several meters thick. They come from transformation of the matrix into colloidal elements, including kaolin, hematite and a proportion of silica, about 30% of the whole. The ferritic soils are protected by the forest covering from erosion, and contain little organic matter or humus. In the Sudanese regions with a marked dry season there are tropical ferruginous soils, which are much shallower. These are rich in iron oxide, with a sandy surface and clay at lower levels. They are very unstable and are sensitive to water and wind erosion. Their structure deteriorates very rapidly on the surface when plant cover is lacking. These soils are frequently caked or plated in West Africa, where the process of gullying during the rainy season alternates with intense desiccation in the dry season, especially when the harmattan blows. In some regions to the north of the coastal fringe of the Gulf of Guinea, there are ancient denuded erosion surfaces, plated or with hard pan, called boards. These are characterized by large accumulations of iron oxide and alumina, with hardening at shallow levels. But many of these ancient house date from the Tertiary era. Their hardened surfaces broke through after the erosion of the loose upper levels. Everywhere such soils are of very limited value in farming. Similar soils are found in Madagascar on the Tambojetsa to the northwest of Tananarive. Further north in the northern hemisphere, brown structured soils, of great agricultural value, have formed in a climate with contrasting seasons under herbaceous cover. Despite their sensitivity to gullying, they permitted the evolution of agrarian cultures associated with the great Sudanese empires of the pre-colonial era. South of the equator, in the countries watered by the Zambezi, lightly gullied soils resembling podzolic formations were constituted under cover of the dry forest. In the north and south, in the subarid regions near the Sahara and the Kalahari, there are brown steppe-like soils consisting of more or less fixed dune sands with clay sand formations in the depressions. Light and loose, they are good for farming, but to allow them to regenerate, long periods of bush or grass fallow are necessary. In the arid regions where mechanical forms of erosion are predominant, there are wide variations in temperature. 329. Methodology and African prehistory, in which the rocks tend to break up and the violent action of the wind and the sparse rains cause sheet erosion. In these regions there are sterile sands forming ergs, gravel regs covering vast expanses, with clay crusts in the plains. Apart from the oases, the deserts have no soil for farming. In the Mediterranean environments, the action of water and the contrasted seasons brings less chemical weathering to the rocks than in the humid tropical zone. The soils are like those of the dry tropics, with red, gray or chestnut-colored surfaces. They are generally rich in salts. Some, such as the steppe-like soils, are rich in calcium, thus heralding the temperate environments. Others, formed of calcium or gypsum crusts, are characteristic of the Mediterranean zones. Biogeographical areas, climatic and soil factors account for the diversity of the morphological conditions in which the botanical landscapes are formed. Dense moist forests. The most imposing of the botanical landscapes is in the center of the continent, between latitude 5 degrees N and 5 degrees S. Here the characteristic vegetation is the high, dense, moist forest. This is divided into several layers, while creepers and epiphytes accentuate the obscurity caused by the superposition of evergreen leaves. There are, however, gradations, marshy thickets on wet clay soils, or the clearings which herald the change to dry air conditions. The species found in the moist forest are so diverse and mixed that their exploitation is difficult. With constant heat and humidity, exuberant vegetation thrives and microorganisms, worms and insects abound. This environment is hostile to man, despite its silence. It is inhabited by a wide variety of animals such as the hippopotamus, the elephant, the bush pig and the leopard. But it is the tree-dwelling birds, reptiles and mammals that can move easily and multiply despite morbidity factors such as the many parasites. Outside the equatorial zone, the great moist forest can exist on high land long exposed for much of the year to moisture-bearing winds, for example, on the eastern slopes of the high Madagascan plateau. Savanna and open forests. The rainforest zone is bordered by the dry deciduous forest characteristic of regions with rainfall concentrated around the solstices. It is often open, with the trees only partly covering bush and plant undergrowth. When overexploited by man, this landscape gives place to grassland characteristic of regions with a more marked dry season. Tropical savanna emerges as the low latitudes are left behind. This vegetation associated with areas with seasonal climates contains some elements of the more or less humid plants of the tropical climates. At the edge of the forest, in the woodland savanna, there are still large. 330. Historical geography, physical aspects. Trees, but they are less frequent than bushes, and the grass cover becomes more important. Gallery forest, in strips of varying widths, borders the rivers. In the savanna parkland there are wooded spaces next to areas with lush cover, which are populated mainly with tall grasses. There are grassland savannas devoid of trees, doubtless because of man's deforestation and the caking of the soil. Further away from the dense forest, the grassland savanna composed of a continuous carpet of tall plants gradually gives way to scrub savanna where the soil is often bare between patches of plant cover. Herbivorous wildlife finds favorable living conditions in the different kinds of savanna. Hunting is good and stock raising possible. Man finds it easy to farm in these lands, which are not hard to clear. Steppe lands. Steppe, consisting of grass tufts and prickly thorn bushes, notably acacia, is typical of regions with a long dry season. This open landscape is found in the northern parts of West and East Africa, and more sporadically in South Africa, in the Kalahari and southwestern Madagascar. Subdesert vegetation of poor steppe is found in regions with less than 200 meters at rainfall. Mediterranean vegetation at the tips of the African continent. There are bushy or grassy steppes in the driest regions. But in the more humid zones, notably the mountain ranges of the Maghreb, there are dry forests of green oak, cork oak, pine and cedar. These trees have evergreen leaves dominating a bushy undergrowth. Conclusion: Africa is an old continent which, from very ancient times, has been occupied by a people that very early developed splendid cultures. Africa's geography, in its structural features as well as in its natural environment, displays vigorous characteristics inherited from a long geological past. Africa is more massive and continental than any other continent. Vast regions in the heart of the continent, more than 1,500 kilometers from the sea, long remained outside the major circulatory flows which explains the importance for human settlement, since prehistoric times, of great meridian troughs like the Rift Valley of East Africa. This geographical isolation was strengthened near the tropics because of climatic variations in the Tertiary and Quaternary eras. For thousands of years the humid Sahara was one of the world's oldest centers of human settlement. Later, dry phases helped to form huge deserts such as the Sahara and the Kalahari. Exchanges of all kinds between the different cultures of the continent suffered but were not interrupted. Climate, then, is an essential factor for an understanding of Africa's past. Moreover, rainfall patterns and the bioclimatic environment have a real influence on the life of the end today. African societies have in fact taken 331. Methodology and African prehistory. Advantage of the complementarity of climatic zones to establish between themselves long-standing and vigorous flows of trade. Finally, the history of Africa has been markedly influenced by its mineral wealth, one of its most powerful attractions for conquering peoples. The gold of Nubia and Kush was exploited by the dynasties of ancient Egypt. Later, the gold of tropical Africa, notably of the Sudanese region and Zimbabwe, became a source of prosperity for the societies of North Africa and the Near East, and the mainstay of the great African empires south of the Sahara. Iron was traded in ancient times between the forest and the tropical regions of Africa. The salt mines on the edge of the Sahara played an important role in relations between the black states of the Sudan and the Arabo-Berber peoples of North Africa. Recently, Africa's mineral wealth has been exploited on behalf of colonial powers. Today it is still mainly exported as raw material. Iron, manganese leather, tin, cobalt, bauxite, diamonds, uranium, cobalt V** centiliter USSR, phosphates. 025 50 75 100%. Figure 14. By Mineral Resources of Africa after Journas, /076. 332. Historical Geography, Economic Aspects. ALMBOGUNAE. According to Gilbert, the real function of historical geography is to reconstruct the regional geography of the past. 1. In the volume such as the present, such a definition would imply an attempt to present the regional geography of African prehistory with special emphasis on the economic aspects. Such an attempt clearly would involve a comprehensive review of both physical and human conditions in the distant past and is sure to overlap with many other chapters in the volume. In the circumstances, the emphasis in this chapter is to consider the natural resource base, especially in terms of how this was perceived and utilized in prehistoric Africa. Such a consideration, while emphasizing the broad spectrum of the continent's natural resources as known to us today, will seek to underline which of them were appreciated as such in the distant past, where they were found, how they were used and to what extent they aided or hindered man's control of large areas of the continent. Minerals and the development of human technology. Perhaps the most significant of natural resources for the human mastery of his environments are minerals. Minerals are the material of which the world is made. In general, they are formed by processes which are extremely slow and which may run into millions of years. In consequence, compared to the human occupancy of the Earth, which goes back barely 3 million years, the geological time scale is extremely long, covering well over 5,000 million years. Large parts of Africa are underlain by rocks, which are some of the oldest in the world. These ancient, crystalline rocks, which are referred to as basement complex rocks, cover at least a third of the continent. They are comprised largely of granites as well as highly metamorphosed rocks such as schists and gneisses. Some of these rocks are highly mineralized. The most important of such formations are those found in the copper belt of Zaire and Zambia, which extend for a distance of over 300 kilometers. Besides containing the largest deposits of copper in the world, this belt also are for 1. E. W. Gilbert, 1932, page 132. Methodology and African Prehistory has some of the most complex deposits of radium and cobalt. The Bushveld igneous complex in Transvaal, South Africa, an area of 95,000 square kilometers, as well as the Great Dye that runs through Transvaal into Zimbabwe, a distance of 530 kilometers, forms another highly mineralized zone. The minerals here include platinum, chromite and asbestos. The African diamond zone has no equal in the world and shows its greatest concentration in South Africa, although smaller deposits are found in Tanzania, Angola and Zaire. Gold fields also exist in South Africa, Ghana and Zaire, and tin is to be found in Zaire and Nigeria. There are also rich deposits of iron ore such as those in Sierra Leone, Liberia and Guinea in West Africa. The ancient basement complex of Africa has also suffered frequent volcanic disruptions going back even to the Precambrian times. These disruptions have given rise both to granitic intrusions with which gold and tin are associated and to the intrusions of basic and ultra-basic rocks. They have also produced eruptive or effusive rocks, many of more recent age, which, apart from weathering down into good, fertile soils, have provided minerals and rocks such as the obsidian basalt in Carrion of real significance for the history of the continent. Over much of the remaining two-thirds of the continent are found old, sedimentary rocks of pre-Cretaceous age. Because of their age, these rocks also contain notable mineral deposits along the northern rim of the continent. For instance, in an area extending from Morocco through Algeria to Tunisia is the Great Phosphate Rock Belt, associated with which are iron deposits of considerable importance. Similarly, important iron ore deposits of sedimentary origin are found in the Karoo region of South Africa and in the Damara systems of Namibia. Coal deposits are, by contrast, notable by their virtual absence in Africa except for a few isolated occurrences in the high veld of South Africa and the Wagyu field of Zimbabwe. As if to compensate for this deficiency, the younger sedimentary rocks of post-Cretaceous age in the Sahara and coastal areas of West Africa have been found to contain vast deposits of petroleum and natural gas. These sources of mineral wealth provided much of the economic underpinning for human organization and exploitation over a long period of history. It has been suggested, for instance, that the control of the trade in gold between West and North Africa across the desert was one of the major reasons for the rise and fall of empires and kingdoms in the western Sudan during the medieval period. The trade in gold and iron ore certainly attracted the Arabs to East Africa from the last millennium onward. The Europeans, on the other hand, were initially distracted by the mineral wealth of Latin America, but in the last 100 years they have concentrated on Africa as a colonial reserve of mineral raw material to stoke their industrial growth. Yet in the prehistoric period, the minerals that were of fundamental importance for the gradual technological development of man were of more